For our next model, this is called the AIDS model, which simulates the spread of the human immunodeficiency virus or HIV via sexual transmission through a small isolated human population. So here we have different sliders. The initial people here, which can be maxed at 500. The average coupling tendency means that the general likelihood member of population has sex, maximum of 10. Average commitment is how many weeks sexual relationship typically lasts, 0 to 200 weeks. Average use of condom, which means that the general chance member of population uses condom. And the average test frequency is the average frequency member of population will check their HIV status in a 1-year time period. Here, you can see the HIV negative, HIV positive, and HIV unknown. You can also see here the green patches to show that there is coupling between pairs or between the population. You can also see at the bottom part of the program here the graph of the HIV negative, HIV positive, and HIV unknown. There's also initial 2.67% infected for this simulation. So, by having a 300 initial people, average coupling tendency is 10, average commitment is 100 weeks. So press setup. We have already a 2.67% infected, which, as you can see in the blue colors. Okay, then press go. You can see there a gray patch, which means that this gray patch are couples coupling together for a span of 100 weeks. So as you can see, all the average coupling tendency at 10 and the average commitment at 100 weeks, there is a slow percent infection of HIV. So this means that individuals that continue to move out are not engaging in sexual relations because they have monogamously have a relationship with one person. But after this 100 weeks, they couple again to another person and engage in sexual relationship. This will give a tendency to have an increased percentage in infection. Okay, as you can see there, that there is an increase in the number of red, which is HIV positive. Now, let us set up an average coupling tendency of 10, average commitment at 1 week, average condom use is 0, and average test frequency is 0, with an initial people of 300. Set up, then with an initial 2.67% of infection. So as you can see, there is an faster increase in the number of unknown HIV positive or negative. If there is no use of condom and there is no test frequency and there's only 1 week relationship between couples. As you can see, there is a 99.67% infection for the HIV. And as you can see in the population graph, for about some weeks, there is a significant increase in the unknown HIV positive or negative. As we go on further, there is an increase in the number of HIV positive, and there is a 100% infection. Another scenario is we have a average coupling tendency of 10, average commitment is 100, and average condom use is 5, and there is only a one-time frequency per year for HIV test. Okay, set up. Then initially we have 2.67% of infection. As you can see, there is a more coupling or gray part in the area because there is a 100-week relationship or commitment, and there is a slow rate of infection of HIV, since there is a 5 average condom use and 1 time HIV test per year. This is also can be seen in the graph. So lastly, if we set all sliders into maximum, 10 for average coupling tendency, 10 commitment, 10 condom use, 10 or 200 weeks for average commitment, and 2 times per year average test frequency, with a 2.67% infection. So as you can see, there is a much longer gray patch in the area, which signifies that there is a longer commitment between couples. And the percent rate of the spread of the HIV is significantly slower because of there is a tendency of the use of condom, and there is a 2-time HIV test frequency. So that's how you simulate the AIDS model with these sliders.